Lesson: AI techniques for language translation. Artificial intelligence techniques have revolutionized the field of language translation, transforming how information is shared across linguistic barriers. At the heart of this transformation lies natural language processing, a subfield of AI focused on the interaction between computers and humans through natural language. NLP techniques form the backbone of modern translation systems, enabling them to understand, process, and generate human language in a manner that is both meaningful and contextually appropriate. This lesson delves into the intricacies of AI-driven language translation, highlighting actionable insights, practical tools, and frameworks that professionals can employ to address real-world challenges and enhance their proficiency in this domain. Machine translation is a critical application of NLP that involves the automatic conversion of text from one language to another. Historically, rule-based systems dominated the field, relying on linguistic rules and dictionaries to perform translations. However, these systems were limited by their inability to handle the complexities and nuances of natural language. The advent of statistical methods marked a significant shift, with systems like Google Translate leveraging vast corpora of bilingual text to generate translations based on probabilistic models. Statistical machine translation improved translation quality by considering multiple possible translations and selecting the most likely sequence of words. Despite these advancements, SMT faced challenges such as handling idiomatic expressions and maintaining contextual coherence. Neural machine translation emerged as a superior approach, utilizing deep learning models, particularly recurrent neural networks, to capture the sequential nature of language. NMT models, such as Google's Transformer, further enhanced by attention mechanisms, have set new benchmarks in translation quality. These models consider the entire context of a sentence, allowing for more accurate translations that preserve meaning and fluency. For professionals seeking to implement AI techniques in language translation, understanding the architecture of NMT models is crucial. The Transformer model, for example, employs a sequence-to-sequence architecture with an encoder and decoder. The encoder processes the input sentence, converting it into a series of vectors that capture its semantic meaning. The decoder then generates the translated output, word by word, using these vectors as a guide. Attention mechanisms within the model ensure that each word's translation considers the relevant parts of the input sentence, thereby maintaining contextual integrity. Practical implementation of NMT requires an understanding of various tools and frameworks. TensorFlow and PyTorch are two widely used open-source libraries that provide the necessary infrastructure for building and training deep learning models. These libraries offer pre-built modules for implementing NMT, such as the Transformer, enabling professionals to focus on refining model parameters and optimizing translation quality. Hugging Face's Transformers library further simplifies the process by offering pre-trained models that can be fine-tuned for specific translation tasks, significantly reducing the computational resources and time required for training from scratch. Real-world applications of AI-driven language translation demonstrate its transformative potential. For instance, e-commerce giants like Amazon and Alibaba leverage NMT to break down language barriers, allowing them to reach a global customer base. By providing product descriptions and customer reviews in multiple languages, these companies enhance the shopping experience and boost sales. Similarly, social media platforms such as Facebook employ NMT to facilitate cross-cultural communication, enabling users to interact seamlessly regardless of their native language. These examples underscore the importance of AI in fostering global connectivity and inclusivity. Despite its successes, AI-driven language translation presents several challenges that professionals must address. One significant issue is the handling of low-resource languages, which lack the extensive bilingual corpora necessary for training robust NMT models. Approaches such as transfer learning and unsupervised translation have shown promise in overcoming this limitation. Transfer learning involves pre-training a model on a high-resource language pair before fine-tuning it on the target low-resource language. This method leverages the knowledge gained from the high-resource pair, improving translation quality. Unsupervised translation, on the other hand, relies on monolingual corpora, using techniques like back translation to iteratively refine the model's output. Another challenge lies in maintaining translation quality for domain-specific content, such as legal or medical texts. Domain adaptation techniques address this issue by fine-tuning NMT models on specialized datasets, ensuring that the translations adhere to domain-specific terminology and conventions. Tools like OpenNMT and MarianNMT offer functionalities for domain adaptation, allowing professionals to customize their models for specific use cases. In addition to technical challenges, ethical considerations play a crucial role in AI-driven language translation. Bias in training data can lead to skewed translations that perpetuate stereotypes or exclude minority dialects. Ensuring equitable representation in language resources and incorporating fairness in model development are essential steps in mitigating these biases. Techniques such as data augmentation and bias correction algorithms can help create more balanced training datasets, promoting fairness and inclusivity in translation outputs. The future of AI-driven language translation is marked by ongoing advancements and innovations. Research in areas such as multilingual models, which can handle multiple language pairs simultaneously, and zero-shot translation, which enables translation between language pairs without direct training data, holds promise for further expanding the capabilities of NMT systems. As these technologies evolve, professionals equipped with the knowledge and skills to implement and refine AI techniques for language translation will play a pivotal role in shaping the future of global communication. In conclusion, AI techniques for language translation have transformed the landscape of communication, enabling seamless interaction across linguistic boundaries. By leveraging NLP, deep learning, and innovative frameworks, professionals can harness the power of AI to address real-world challenges and enhance translation quality. Understanding the intricacies of NMT models, utilizing practical tools and frameworks, and addressing challenges such as low-resource languages and domain-specific content are critical steps in mastering this domain. As the field continues to evolve, ongoing research and ethical considerations will shape the future of AI-driven language translation, fostering a more connected and inclusive world.